Today we're going to do a Leaving Cert perspective question from 2010. It is the ordinary level question. Starting off, always start with reading the question and see what information it tells you and what we have to do. So it says 3D graphic on the right shows the model of a tent which has a side window. Figure B3 shows the plan and elevation of the tent. So we've got the plan down here, elevation up here, and it says part A, draw the given plan. Now we know from perspective questions, generally we're always going to kind of do the perspective as the person's eye view. He's going to be down here somewhere. We see the spectator is here. It's facing away from corner A, down here somewhere, and it's going to probably give us a distance of how far that spectator is. And what we're trying to do is draw their eye view or their perspective of what they see here, if we can imagine them standing in front of it. So the important information we also need from the elevation is various heights. So we can see the kind of side window here has a height of 50, so that's going to be important later. The base is 15 high before it starts to kind of taper up, and then we've got the overall height of it is 65 as well. And we can see then in plan it has a 60-degree inclination to the vertical plane. So basically 60 degrees there, we can see that this is a right angle, so that's going to be 90 degrees in there, and 1690 we can work out this angle obviously is 30 degrees. So starting off, we draw our plan, keep it roughly top of your page, and we will use the elevation then for our heights later on. Okay, so there we go, plan drawn, and now what we have to do is we're going to look at the part B of the question where we are going to draw our perspective. So it says make a perspective drawing of the structure given the following. The spectator point is 70 millimeters from corner A, so from corner A straight down we're going to measure 70 millimeters. The picture plane is touching the corner A, so basically our picture plane, if you imagine a blank page or plane touching corner A, so that means at corner A, any point touching there we can actually take a true height from. And then the horizon line is 30 millimeters above the ground line, so 30 millimeters high, that is going to dictate where our vanishing points are, which are going to be parallel with our extreme edges going to the right and going to the left, which are going to give us all lines in this direction going to the right and all lines going in this direction to the left. So we'll set that up. So from corner A, always use labels, very important. So corner A, measuring down straight 70 millimeters. So straight line down, measure on that afterwards, 70 millimeters. So at this point here I have my spectator. Okay. Now I'm actually going to use a red pen for this because I think this is a critical piece of information. So from the spectator out to your extreme edge here on the left, or extreme point I should say, and your extreme point on the right. So if we imagine a person standing here at this exact point here, what they're looking at is this is far right of the object they see and this is far left of the object they see. And this area inside here is known as their cone of vision. Now, what we have to imagine is how would we get the middle of that cone of vision, which is basically their line of sight. If they're staring at this object, they're always going to be roughly staring right at the middle of it, and their peripheral vision will go off to the right and it will go off to the left. So, like with any angle, what do we do to get the middle of it? We bisect it. So, get your compass. Bisect it from the spectator through this very important point. Now we have our line of sight, and perpendicular to our line of sight we can now draw our picture plane, which is going to pass through the corner A. So set it up. This line of sight square is very handy. From here, pass through the corner A, rotate it around, just to show some people that. Set it up with the long edge of the 45, put the other set square underneath it, rotate around, 90 degrees. And with that picture plane, I'm going to also put in that in nice and heavy so that we can see it. Okay, I just extend it out a tiny touch further to the right. And for picture plane, I would always label it picture plane, PP. For today, I'm going to write in picture plane, so everyone can see it. Nice and handy. Now, before I actually move on to the next part, what I would actually do now is I'm going to do a little step that's going to help me determine my vanishing points on the horizon line later on. So, from the spectator, I'm going to go parallel with this extreme edge. Okay, this edge of the building is at 60 degrees. So 60 degrees from the spectator, and then I'm going to parallel with this edge because I've got various lines going in this direction, this one, this one, this one, this one, and them lines are at 30 degrees. So spectator over to hit my picture plane. Now where it intersects the picture plane here and here, once I drop them down to my horizon line, when I set that up in a minute, that is going to determine where my vanishing points are. VP1, VP2, down here in a minute. So the next step is setting up the ground line and the horizon line. Now at this step, when I'm teaching it in class, what I often do is I usually get my students to rotate their page. Basically what I do is, in line with the T-square, I'm going to set up the picture plane in line with the edge of the T-square. So, bear with me there a second. Okay, so set up there, nice and easy. Just move that up a little bit so we've got a little bit more room to play with. And I'm going to set up my ground line down here, just roughly a distance. Let me actually go back to the question. It says the horizon line, if we can remember, is 30 millimeters above the ground line. So the ground line can be actually set up anywhere, okay, as long as the ground line just has to be parallel with the picture plane. So from the bottom down here, just going to keep it so it fits on the screen nice and neat and tidy. I'm going to do a ground line. Now, my ground line, I'm after making it roughly the same distance as my picture plane. That doesn't matter. The ground line could actually be this distance, this distance, this distance. The only reason I'm going to use a ground line is because we know corner A is touching our picture plane. Therefore, corner A, if I go over to my sheet, which would be here, therefore this point here is corner A. Therefore, if I just go to the graphic, it would be this point down here. Okay, and straight away I can take that height there, which is going to be corner A, in a minute. So, corner A, which is there, I can drop it down. That's going to be on my ground line in a second. So, ground line. Usually you can just mark it with GL, but for the sake of this video, I'll just put it in so everyone can understand it. And 30 millimeters above my ground line is my picture plane, or sorry, horizon line, apologies. So, there's 30 millimeters. I'm going to set this up. Nice light line across my page. Okay, and if you can remember when I said we were getting the vanishing points, parallel to the extreme edge on the left, parallel to the extreme edge on the right, 60 degree line, 30 degree line from the spectator. So these lines are parallel, that is the relationship between them. So if I just make that there and that there, okay, to my horizon line. So, and that will determine for me this point here, which I'm going to label VP1, and this point here, which I'm going to determine VP2. So, now that we're all set up, we have part A, our plan drawn, we have our pitch plane set up, going through the corner A. which was determined by bisecting the cone of vision to get the line of sight, and perpendicular to the line of sight is the pitch plane. From the pitch plane came down, I set up a ground line. It doesn't matter if I set the ground line up here, here, or even down further. It does not matter. I just kind of keep a rough distance so it keeps it neat and tidy on the page. And then our horizon line was 30mm above the ground line. And our vanishing points were dictated by, from the spectator, which is in this position, parallel to the extreme edge going this way. So parallel from the spectator to where that hits the pitch plane at this point, drop it down, you get VP1. And then parallel to the extreme edge on this side, from the spectator, where it hits the pitch plane right in this corner here, at that corner there I'm going to drop it down and I get VP2. So at this stage we're kind of now set up to complete our perspective view of the drawing. So what we look at when we see the drawing is we see corner A is touching the pitch plane. That means that corner there, I can determine any point from there, I can take a true height from. And we know corner A, if we go back to our sheet, has a height of 15mm. Okay, so at corner A, when I drop that down, that is going to, I'm going to measure up on that just to get this first edge to start off the drawing, and it's going to be 15mm high. So corner A is here, so straight away I'm going to drop him down, and he's going to be a height of 15mm. So I'm going to measure up there, 15, right there, and straight away I can heavy that in, because I know that is one part of my perspective view ready to go. I like to build it up because I think as we heavy it in as we go, we can kind of see in certain parts kind of how it's going to build in the structure. So if we actually just take this structure for a second, we can see that you kind of have a triangular section on top, which is the top of the tent. We obviously have this window part. We'll get onto that bit at the end, but I'm going to take it in 3 sections. So the base part is like a little block, okay? That's 15 high, and obviously we can see that it's 60 wide back here. So I'm going to actually build up that kind of just square base at the start, and then we'll get onto the triangular part and then the window. So starting with the square, I've got the first height set up already, 15mm. Now, if I want to find the back edge of the square, I've got this corner, I've got the bottom point here, and the top point here, which is all coming from this. The far edges will be here, the back one here, which we probably won't see as we looked at it, and this one on the right. So we will see this one, and we will see this one over here. And what we have to do is we have to draw the spectator's view of those objects. Now, corner A is on the pitch plane, but this corner here, now he is not touching the pitch plane, he's actually behind that pitch plane. So in reality what the person would see is this point is actually further away than corner A. But what we have to do is we have to draw the image of that point as the person is going to see it on the pitch plane. So where that point actually hits the pitch plane is right here. And it's the same with this guy over here. So where they hit the pitch plane, we're going to drop them straight down. Okay, and somewhere along these lines is going to be top point here and the bottom point, the one that's on the ground and the one that's 15mm high, and the same with this one. And we've already got this first edge here. So for lines that are going in this direction, we are going to go parallel, and we can see that they're going to vanish to VP1. For any lines that are going in this direction, they're going to go to VP2. So, very easy. From the base, going to move it over to VP1, and I'll do the same from the top point. And for lines going in this direction, exact same as well. VP2, VP2. And what you'll actually notice is I've actually got kind of the edges of my base already. Now, if I did really want to complete the box, at this point here, I know that's the top point, and this point here is at the back on the other side. And you can actually see, if it's kind of hard to determine now, but looking here, 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 that's 2 faces, and there will be the top of the box in there in that section. Okay, but we know we can't see the top of the box because that's where the tent is starting. So what I will do is, I'm just going to heavy in as much as I know I can at this moment in time. And I also know I have an edge right here. So, next part of the question. We have to build the section that's going to be basically going up here like the triangular part of the tent. Okay, and it's going to come over here and it's going to come up here as well. So what we have to look at is, if we look at our elevation, we can see that the height from the ground all the way up to the top is 65 millimeters high. So I know the top point right here, this point and this point are both at a height of 65 millimeters. So on my sheet I know that I'm actually looking for this point and this point. Now once again I have to get the spectator's view of it. So what am I going to do? Anytime we want to find a point, specifically this one and this one, what I need to do is I need to bring those points down to the spectator and see his view of it. But what I always do is I bring it to the spectator but stop it at the picture plane. Because if you stop it at the picture plane, that is the person's or the spectator's view of the actual object on the picture plane. So same thing with this point, bring it down to the spectator, stop it at the picture plane, and then drop it down. Somewhere down along there is going to be, somewhere down along this line is going to be the top of it, and somewhere down along here is going to be the top of it the other side. And the reason I haven't brought them the whole way down is because I know it's 65, so somewhere up around here, I'm just guessing, I might have to bring it down a little bit further, I don't know just yet, but I'm guessing that it's going to be in around here somewhere. So that's why I just didn't bring it the whole way down, just keeping it drawn neat and tidy. Now, what we're actually getting onto here is doing height lines. Okay, so there's two ways I could do it, and I'm actually going to show you both ways. And it's all to do with planes. So I'm actually just going to kind of do a little quick sketch here. Now I'll just zoom in there a little second. So the point I want to find is right here. And that point there is actually on a plane surface. Because if you just follow the outline of my pen, it's on that surface there. If you imagine I was making a sort of a triangular shape there, that's actually a plane. But when we think of planes, often when I explain it in my classroom, it's like a flat piece of paper. So I'm just going to extend that down there. And imagine there we have a square piece of paper right there. That is one plane. And on that plane I have a point. Okay? So to be able to do that, I already know this corner here was corner A. So we'll just put in that there, corner A. This corner here was corner A. This point here was up 15 millimeters. And we know the height of this is 65. So that would mean then that this height here is also at 65, if that makes sense. So, looking at my plan, A is here, this is still A, this point here as we're looking at it in plan is still A, and it's at a height of 65. So one way I could do it is, from A, which is down in my plan, and I'll zoom out now again, from here I could measure up a height of 65. Right there, that's my little mark. And on our sheet, that plane that I created was here. But when I look at it in plan, I would see it as a line. And that line is this going in this direction. If we look at it on our sheet, it's a plane there, it's going in that direction. So from that height of 65, we know then any lines that are going in this direction, which is the way the plane is going, they are going to vanish to VP1. So at 65, I'm going to bring it down. I'm going to bring it down to VP1. And where that line, or where that height line comes from, and where it cuts through, where this point is here, determines the top of my roof, or of the tent I should say. So that means I found a point. I can now draw in my edges. So there, I've found one side of the tent. I'm actually going to do just another way, just to show you now, another way of determining the height of that tent. And it is another way that students often wouldn't realise or wouldn't figure out as well. And I will use another sketch here. So, zooming back in. Okay, so what we did was we determined that there was a plane there. Another place that there is a plane is technically here. That point there, right on this corner, if I was to bring a line down, go up at whatever angle it is obviously an isometric, over to the top point here. Now I've got another plane, only going in this direction. And in our plan view, we would once again see that as a line, and that line, in this case, is here. So the way we can actually determine this point or this point, because in this one we actually have 2 points that are on that plane. We've got this one and this one, and we know once again they are both at a height of 65 millimeters. So the method for finding that, I will show you now. And once again, it should give us this exact point here. So what we need to do is we need to create that plane. And we know that plane in plan. I'm going to put this in red now, so because it's a very important point. That plane, we see it as a line right here. I'm going to extend that plane down to my picture plane. And it's after hitting right at this point there. Where that hits the picture plane, I'm going to now drop it down to my plan, or sorry, to my ground line. And it hits it right here. From here, like we did over here, we can measure up the height of it, which is going to be at 65 millimeters. So 65. And from that 65, the plane in this case was going in this direction. So any lines going in that direction have to vanish this way. And in that direction it's going to VP 2. So from here, I'm going to vanish it across, and we can see by vanishing it across, it went through the exact same point. So we know then that we have it done right. You don't have to do that, but that's just showing you 2 methods for getting the same point. It's just recognizing where the planes are and how you're going to use them to your advantage. So, in the case of determining where this point is now, we already have this guy here, which was here. In the case of determining where this guy is up here, we can see that the line is going in this direction, so we know from here, which is there, we have to vanish across the VP2, which we have already done. And it's a case then of finding where it finishes, and it's going to come down here, and where that line crosses through, right there. And that point there is our other edge. Just heavy in that now, same thing. Now I've started to kind of build up the structure, and the last bit we have left is this little window inside in here. And the same thing, we're going to use height lines once again, only this time, what height is the window? 50. So this edge here, very, very important. Right there, because it's at a height of 50. There are other points we can actually determine straight away, because now we do have this top edge, which is there, we have that, we can determine this point and this point by just bringing them down to our spectator and bringing them down to our perspective view. So, with that in mind, I will do that. So I'm going to bring down this point here, because we have that edge already, bring him down to my spectator, stop it at the pitch plane, bring him down to my spectator, stop it at the pitch plane, and bring them down to my drawing. And there you go. And I have determined 2 points. Right here and here. Now, I've determined this point and this point. The next part, when we're actually looking at this drawing, so I have this guy here and this guy here. We're trying to build it up. We know he's at a height of 50. However, we don't know this point here and this point here. It doesn't give us any height on the actual sheet. It doesn't tell us what height this point and this point is. But what we can recognize is, if we have this one and this one, what's the relationship between that line there and that line there? And we can see that they are parallel. So we know that obviously this point here is going down along that face. So there's 2 ways we could actually find it. If I was to continue, let's put this in pencil here. If I was to continue that line down parallel, it would hit down here. And the same with this one. And that actually then, because we have this edge already, would give me a definitive point right here and right here. So I'm actually going to use that method, because when I look at that in plan, I've actually got this line in plan as far as here, but I don't have it as far as here. So in plan, I'm actually just going to extend it down. So we can see in our plan view, this was the line. I'm going to extend it down to that edge by literally just bringing it down there and down there. and I can see I have a point right here and right here. And like I found this one and this one, I'm now going to find this one and this one. So same thing, same method as always. Down to your spectator, where it hits the pitch plane, stop. Down to our spectator, where it hits the pitch plane, stop. Drop it down in plane. And zero. And yeah. And where they hit in plan, I can now create those parallel lines. Now they mightn't appear parallel in our perspective view, but in reality we know that they are. And what we can actually see there is along that line and that line, I have now found, just to go back in here, this line and this line. And somewhere along these lines is this point and this point. And how would I find them? Same method as we've just been practicing. So the definitive points are here. So same thing, bring him to my spectator, hits there. Bring him to my spectator, hits there. And what do I do? Or sorry, where I hit the pitch plane, where it hits the pitch plane, drop it down. That's going to give me a point right here. So I know now I can heavy in that edge. And somewhere along that edge, this line is going back in that direction. So what am I going to do? Vanish it over to VP2. And I know it's going to stop about there, because that's where it hits on the other side. Just to prove that that was the point, what could I do? Where it came here, brought it down to my pitch plane. It should, depending on my accuracy and how accurate I am, match up. And I'm pretty happy with that. That's not too bad. Probably out by like half a mil. But obviously I am using pens and should have probably my pencils sharpened as well. So now the last part to complete this question is we have this point here, it's at a height of 50, and once again, how did we find this guy? We used the height line at 65, so that's why these heights are very important. This point here, very important. We're going to do a height line at 50. So there's two ways once again we could do it, but I'm just going to use one. From here, I am going to extend down, imagine creating a plane on that surface. So if I just do the sketch again, once again, creating another plane, and this time it's out a little bit, so from there, very important, imagine creating another plane. And probably bring it in here a little bit. I'm creating a plane that I'm going to extend down to my pitch plane. So that plane, and obviously on that plane I've got a point here and a point here that are both at a height of 50. So in doing that, get this done nice and quickly. From here, I'm going to extend him down as far as my pitch plane, where it hits this point here on my pitch plane. I'm going to drop him down to the ground line, because I know then from the ground line I can take exact heights of 50 millimeters. Probably should use pencil there on the last little bit, so I have to ruin my drawing a little bit. Line is going in that direction, so which way am I going to vanish? I'm going to go to VP2. And somewhere along there is going to be this point and this point. How do I find them? Well, I've already brought that point down, so somewhere down along here is going to be there. We're going through my 50 line. And at that point there, I have now created my triangle. And it's the same with this guy over here. Right there. That is going to join up with this guy as well. And now it is just a case of heavying it in. There we go. So that's the question completed. Just talking you through that again there. So plan view drawn first. We need the elevation for the heights. The first thing we're always going to do with the plan view is reading the question. It says the pitch plane is passing through the corner A. So once we located our spectator, which was 70 millimeters down from corner A, obviously I've rotated my sheet sense, and then from the spectator I set up my cone of vision to this point and up to this point. With my cone of vision I did my little bisector to get the line of sight, and perpendicular to my bisector is my pitch plane. picture plane, passed through the corner A. Then came down on my sheet, kept it out of the way a nice bit, set up my ground line, which was down here, and 30mm above my ground line was my horizon line. And to get the vanishing points, which are always going to be in the horizon line, you go parallel to the extreme edges from the spectator. Parallel with the extreme edge on the left, going that way, hits your pitch plane, chop it down, you get your VP1. Parallel with the extreme edge on the right, hits your pitch plane right here, drop it down, you get your VP2. So at that point we're all set up. From A, which was here, right here at this corner, I know I should have actually labelled it, there's corner A. Corner A, I can actually take true heights from that, and the first part of it was up 15, and we vanished off to the right, we created that little base in the bottom. Then, the top of the tent was at a height of 65, two ways I could have done that. From A, I could have measured straight up 65, and it was a plane going in this direction, so I vanished it to the left. So from 65, went through that way, gave me a point here, once found. Another way I could have done was from here, and here I extended it down to the picture plane, which I brought down to my ground line, and from there I measured up a height of 65, only this time the plane was going in that direction, so I'm going to vanish it over to this way, which was in relation to VP2. So another 65, but it gave me the same point. It's just recognising that you can use two ways of getting it. So once I set up that, finished the top of the tent. The last bit we had to determine was this guy here, and he is at a height of 50mm. But before I did that, I needed to find definitive points. I had a point up here and a point here, which I located here and here. And I recognise when we look at the drawing that we had parallel lines going here and here that are parallel with the face of it. So another 2 points I wanted to determine to give me a line there so I could kind of guide it was this point here and this point here. So I made them on my plan. So what I did was from here came down, located a fake point here that were going to help me determine where these exact points were later on. So brought them down, came here, came down here, and I joined them up and joined them up. Now I had my two lines, and it was just a case of finding where this point and this point exactly were, which was here and here. So bring them down to my spectator, stop it at the pitch plane, drop it down where it cuts through, gives me that point. Same thing, drop it down, cuts through, gives me that point. But once I had this one, I could have just vanished it off to the left. Now I had these edges here, and now it was just a case of finding this bit, this triangle basically, as we can see in here. So this point and this point were on that. They were at a height of 50mm, we could see from our elevation. So extended them down to my picture plane, hits here, drops it all the way down to my ground line, and from there I measured up a height of 50mm. And from there the line was going in that direction, so we can see then that it needed to vanish over to VP2. So from here, vanish it off all the way to the right to VP2, and where it cuts through then, this point here, once it was brought down, gave me this point. And from there I should be able to complete it. Drawing done.